Hello there, and welcome to Sleepy Science class. I'm so glad you're here tonight, settling in for this quiet journey. Maybe the day has been long and full of little rushes, or maybe you're simply someone who finds peace in letting the deepest, most mysterious corners of the universe carry you gently into sleep. Either way, you've found exactly the right place, a cozy nook where thoughts can slow and the wonders of space can whisper you away. There is nothing you need to do now, absolutely nothing at all, except let your shoulders soften just a bit, let your breathing slow to its own natural rhythm, and allow your mind to drift, weightless and free, like a single snowflake caught in the stillest, gentlest night air, falling without effort, landing without sound. Tonight, we are going to wander together, slowly and softly, into the softest darkness the cosmos has ever made. Black holes. They might sound frightening at first glance, like voids that swallow everything, but tonight, in this calm space, they will feel like old, patient friends, silent guardians of the universe's deepest rests, keepers of the quietest secrets, places where even light itself decides to lie down and sleep without hurry, without fear. If these calm explorations ever help you unwind or give you that gentle nudge toward dreams, consider tapping subscribe, one sleepy soul at a time, sharing this quiet corner with others who might need it too. Now, close your eyes whenever you feel ready, or keep them open just a little, letting the room around you fade, and let's begin our soft drift into the stars. The nearest black hole is more than 1,000 light years away from us here on Earth, so far across the vastness of space that its gravity can never reach you in this lifetime, or the next, or the one after that. Only its whisper can travel to us, a faint echo carried on waves we can barely detect. And that whisper is gentle, ancient beyond imagining, and strangely comforting, like knowing there's a quiet place out there where everything eventually finds peace. Black holes are not really holes at all, not empty pits or hungry maws, as some stories might say. They are the final, soft heartbeat of the largest stars in the universe, a place where gravity has won so completely, so tenderly, that even light chooses to lie down and rest, folding into stillness without resistance. When a star 20 times heavier than our own sun, or even larger, runs out of the fuel that has kept it shining for millions of years, it no longer has the inner strength to hold itself up against the pull of its own weight. So it collapses, slowly at first, like a great balloon gently deflating, then faster, folding inward like the softest sigh you can imagine, until everything it ever was, every atom, every spark of energy, becomes smaller than a single grain of sand on a distant beach, yet heavier than entire mountains made of suns, a density so profound it bends the very fabric of reality around it. At the very center of this collapse, there is a point, a tiny infinite point, called the singularity, where space and time curl up together like two tired cats sharing the same warm blanket by a fireside, nestling close. And our mathematics, the rules we use to understand the world, simply falls asleep there, unable to describe what lies beyond. Nothing that crosses the event horizon, that invisible boundary around the black hole, ever needs to hurry again. Time itself stretches out, slows to a crawl, and finally lets go completely, releasing everything into a timeless embrace. From far away, from our safe little spot in the galaxy, a black hole looks perfectly still, a perfect circle of darkness against the twinkling backdrop of stars, cut out of the star field, as if someone took a pair of cosmic scissors and pressed pause on that part of the universe, forgetting to press play again, leaving it in eternal quiet. They are the quietest places in all of existence. No sound can escape their grasp. No light can break free to tell tales. Only gravity remains, patient and ancient, and kind in its own strange, inevitable way, holding everything close without judgment. Most black holes are born alone, the solitary end of a single massive star's life, but some are born in pairs, two enormous stars that have lived their entire existences side by side, sharing the same corner of space, and when they both run out of fuel, when they both collapse into darkness, they begin a dance that lasts for billions of years, slow, graceful spirals around each other, closer with every turn, closer still, until one day, in the quiet depths of time, they touch and become one larger silence, a merged quiet that echoes softly across the cosmos. When two black holes finally merge like this, they don't clash with noise or fire. They sing, not with sound that our ears could hear, but with ripples in the fabric of reality itself. Gravitational waves that spread out across the universe for billions of years, so gentle, so subtle, that by the time they brush against our little planet, they move atoms less than the width of a single proton, a lullaby from the deepest, oldest past, a song of union in the dark. The largest black holes we know of live at the hearts of galaxies, like quiet kings on invisible thrones, some weighing as much as 20 billion times the mass of our sun. Yet they fit inside a sphere smaller than our entire solar system. Imagine all that immense weight, all that gathered history, resting perfectly still at the center of a slow, endless cosmic waltz, guiding billions of stars in their orbits without ever raising a voice. They do not suck everything in like some cosmic vacuum cleaner, ravenous and unstoppable. No. If our own sun were to suddenly become a black hole of the same mass tomorrow, Earth would keep orbiting exactly as it does now, in the same gentle path. Only the light would go out, the warmth would fade, and the nights would grow very, very quiet. A peaceful darkness settling over everything. Black holes have a perfect kind of memory, but it's a simple one. They only remember three things about themselves: their mass, how much they've gathered over eons, their spin, the soft turning they inherited from the stars they once were, and their charge, any faint electricity lingering from long ago. Everything else, every planet that ever wandered too close, every star that fed them in their youth, every story of light and life is gently forgotten, released into pure, uncomplicated simplicity. No regrets, no echoes, just rest. Hawking radiation, named after a brilliant, gentle man who spent his life explaining the universe to anyone who would listen, is the softest breath a black hole ever takes. At the very edge of the event horizon, where quantum rules play their quiet games, tiny particles appear and disappear like fleeting thoughts, popping in and out of existence so delicately that over time, slowly, the black hole loses a tiny bit of itself, so gradually that the smallest black holes might one day evaporate completely after trillions upon trillions of years have passed, a final quiet goodbye to the cosmos, fading away without fanfare. Some black holes spin almost at the speed of light, twisting the space around them like warm toffee being pulled in a candy shop, creating a region just outside called the ergosphere, where space itself is dragged along in the spin, faster than light could ever go. A gentle cosmic whirlpool you could theoretically ride, extracting energy as you go, and come back to the world younger than when you left. Time borrowed from the turning dark. If you were to fall toward a supermassive black hole, one of those gentle giants at a galaxy's core, your friends watching from far away would see something truly strange. You would slow down as you approach the horizon, freeze there in their view, fade to a soft red glow, and never quite cross over, suspended in time like a photograph, while you, inside your own bubble of time, would drift across in less than a heartbeat, and the entire universe outside would speed up before your eyes, stars racing across the sky, galaxies blooming and fading in one long, beautiful blink, a lifetime of the cosmos compressed into moments. Spaghettification, such a playful, whimsical word for something so profound in its gentleness, is what happens if you fall too close to a smaller black hole, where the gravity is steeper, pulling harder on your feet than on your head, stretching you slowly at first, then longer, longer still, until you become a soft ribbon of starlight, unwinding like thread from a spool, falling asleep forever in the embrace of gravity. But for the truly giant black holes, the supermassive ones that sleep at the centers of galaxies, the horizon is so wide, the pull so smooth and even, you could cross it without noticing any difference at all, just a deepening darkness, a growing silence, and the softest embrace you've ever known. No pain, no rush, just rest. Black holes are the universe's quiet recyclers, taking in everything that falls their way, adding it to their patient weight, transforming matter and energy into pure gravity. And one day, far beyond the lifetime of every star we can see tonight, when the last lights in the sky have flickered out, black holes will be the last remnants left, glowing faintly with that hawking breath until even they fade away, and the cosmos drifts into a perfect, endless rest, a sleep without dreams. There's a black hole only 27,000 light-years away from us, right at the center of our own Milky Way galaxy, called Sagittarius A, a name that sounds like a secret code, 4 million times heavier than the Sun, yet it sleeps most of the time, barely eating the occasional cloud of gas, quietly turning like a lighthouse with no ships left to guide, keeping our entire galaxy in its slow orbit without effort. Sometimes it wakes for just a moment, when a stray cloud of gas or a wandering star drifts too close. It flares softly in X-rays, a brief cosmic yawn that lights up the surrounding dust, then settles back into its long, long nap, undisturbed, unhurried. We have actually photographed a black hole, not with ordinary light that our eyes can see, but with radio waves gathered from telescopes all around the world, working together like a planet-sized eye, capturing a glowing orange ring of superheated gas around a perfect circle of night, the shadow of gravity itself, smiling at us across 55 million light-years, a portrait of stillness from the heart of another galaxy. That first image of the black hole in M87 took years of patience and dedication, thousands of scientists collaborating across continents, and a network of telescopes stretching from pole to pole, just to capture one quiet picture of something that devours light without a second thought, a reminder that even the darkest places can be seen if we look gently enough. Black holes can have what scientists call hair, not real hair, of course, but something discovered only recently in the quiet realms of theory. Soft quantum echoes rippling at the edge, tiny gravitational whispers that might let them remember just a little bit more of everything they once swallowed, breaking the old rule that black holes have no hair, adding a touch of mystery to their simplicity. Some physicists dream in their quiet moments of pondering that inside every black hole, beyond the singularity, a new universe might be born, a baby cosmos blooming like a flower in the dark, so every black hole could be both a cradle for new beginnings and a grave for old ones, a cycle of creation hidden in silence. primordial black holes, born in the chaotic first second after the Big Bang itself, when the universe was a soup of energy, might still be drifting through space today. Some as small as a single atom, others with the mass of mountains or asteroids, invisible travelers passing through stars, planets, even through you, right now, without ever saying hello or leaving a trace. If a primordial black hole the size of a grapefruit were to pass through Earth, it would drift straight through the core, eating only a few atoms at a time along the way, too small to notice, too gentle to disturb, a ghost with perfect manners gliding by. As we continue our quiet drift tonight, let the thoughts from before soften even further, like distant stars fading into twilight. We've touched the nearest whispers of black holes, felt their gentle pull from afar, and now let's wander a little deeper into the moments when stars, those bright, burning hearts of the sky, decide it's time to rest forever. Folding into the softest dark, stars are born from clouds of gas and dust, vast nebulae that swirl slowly in the arms of galaxies, collapsing under their own weight, igniting in a burst of light that echoes across light years. But for the largest ones, those massive giants 20, 30, even 50 times heavier than our sun, their lives are bright but brief, a few million years of shining fiercely, fusing hydrogen into helium, helium into carbon, layer upon layer, like building a quiet onion of elements deep inside. When the fuel begins to run low, the core can no longer push back against the immense gravity pressing in, so the star starts to falter, its outer layers puffing out like a tired breath, becoming a red supergiant, enormous and cool on the surface, but raging hot within, a final swell before the inevitable rest. Then, in a moment that shakes the cosmos, the core collapses. Iron, the heaviest element it can fuse, absorbs energy instead of releasing it, so the heart gives way, falling inward in less than a second, a rush of matter compressing to unimaginable density, bouncing back in a supernova explosion, the brightest light a star will ever give, outshining an entire galaxy for a few short weeks, scattering gold, silver, the building blocks of planets and life into the quiet interstellar wind. But for the most massive stars, the collapse doesn't stop at a neutron star, that dense remnant the size of a city. No, gravity wins completely, pulling everything past the point of no return, creating a black hole, a place where the star's mass now rests in eternal stillness, no longer burning, no longer fighting, just being. The birth of these stellar mass black holes, the smaller ones, 5 to 10 times the sun's mass, happens in silence after the supernova's roar fades. The explosion blows away the outer layers, leaving behind a dark seed, invisible against the stars, but felt in the way nearby light bends, a quiet dimple in space-time. Many such black holes form in the spiral arms of galaxies, where gas is dense and stars are born in clusters, close families that sometimes scatter, leaving the new black hole to drift alone, or perhaps with a companion star, still orbiting faithfully, unaware that its partner has changed into something deeper, darker, more patient. In binary systems where two stars have danced together since birth, one might collapse first, becoming a black hole while the other still shines. The black hole then begins to sip gently from its companion, pulling wisps of gas across the void, forming a swirling disk that heats and glows, X-rays flickering like distant fireflies, a soft reminder that even in death, stars can share their light a little longer. Cygnus X1, one of the first black holes we ever found, lives in such a pair, a black hole about 15 solar masses, orbiting a blue supergiant star, pulling material from it in a slow, steady stream, creating winds that whisper across the constellation of the Swan, a cosmic duet that has played for millions of years and will continue until the companion 2 decides to rest. The quiet after the supernova is profound. The explosion's shockwave ripples outward, compressing nearby gas clouds, triggering new stars to form, a cycle of birth from death, while the black hole settles into its new form, spinning from the star's rotation, twisting space around it like a soft vortex. No drama, just equilibrium. Stellar mass black holes are the most common kind, tens of millions in our Milky Way alone, most hidden, undetected, quietly orbiting the galactic center like everyone else. Their event horizons small, just a few miles across, but their influence felt in the way stars nearby wobble, subtle tugs revealing their presence. When a star collapses, the process is so efficient, so complete, that almost no matter is lost, just transformed from light and heat to pure gravity, a rest so deep it warps the path of everything around it. In the moments before the collapse, the star's core reaches temperatures of billions of degrees, fusing elements in a frantic last breath, creating the heavy metals that will one day form planets, moons, even the rings on your finger, scattered in the supernova's gentle exhale. Black holes born from stars often carry the spin of their progenitors, rotating hundreds of times per second at first, slowing over eons as they drag space along. A Kerr black hole, named after a mathematician who dreamed of turning voids with an ergosphere where energy can be borrowed like dipping a hand into a slow river. The first dance of binary black holes, those pairs that both collapse, begins long before they merge. They orbit each other for billions of years, losing energy through gravitational waves, invisible ripples that carry away momentum, drawing them closer in a spiral so gradual it's like watching continents drift, patient, inevitable, a waltz toward unity. LIGO, the Laser Interferometer Gravitational Wave Observatory, first heard this dance in 2015, a chirp from 1.3 billion light-years away, two black holes, 30 solar masses each, merging into one, releasing energy greater than all the stars in the observable universe combined, but in waves so soft they stretched mirrors by 1,000th the width of a proton. Since then, we've heard dozens more, each a quiet story of stellar ends, black holes finding each other in the dark, coming together without violence, just a final embrace. The birth of a black hole often goes unnoticed. The supernova might be seen from afar, but the hole itself hides, absorbing all light, revealing itself only through companions or lenses, a modest beginning for something so profound. In rare cases, a star collapses without a supernova, a failed explosion, swallowing itself whole, quietly vanishing, leaving only darkness where light once was, a direct collapse black hole, even gentler in its farewell. Stellar evolution leads to black holes only for the heaviest. Lighter stars become white dwarfs, medium ones neutron stars, but the threshold, around 20 solar masses, marks the line where gravity claims total victory. No bounce, no remnant, just rest. The elements forged in these stars, spread by the supernova, seed new generations, so every black hole birth is a gift to the cosmos, quietly enriching the gas for future lights. Binary pairs that form black holes often start as massive twins born from the same cloud, evolving together, one dying first, surviving the other's supernova, then following suit, a shared destiny in darkness. The quiet after such a birth can last forever, unless something wanders close, a stray asteroid, a gas cloud, stirring the accretion disk, a soft glow resuming like embers in a dying fire. Black holes from stars are scattered throughout the galaxy, most in the disk, some flung to the halo by gravitational slingshots, lone wanderers carrying memories of their fiery youth. In globular clusters, dense balls of stars, black holes can form and merge more often. Gravity's crowded dance floor, leading to intermediate mass black holes, hundreds of solar masses, bridges between stellar and supermassive. The first binary dance we detected, GW15914, was two black holes, 36 and 29 solar masses, merging into 62. The missing three converted to pure energy, rippling out as waves, a testament to Einstein's quiet predictions. Stars decide to rest when their cores can no longer fuse, a natural end, peaceful in its inevitability, turning brightness into depth. As we pause here, let these thoughts settle softly, like dust in a still room, the birth of black holes, a transformation, not an end, just a deeper sleep. As we settle even deeper into this quiet night, let the echoes from the stellar births fade softly behind us, like distant waves lapping at a forgotten shore. We've felt the gentle collapse of massive stars, their final sighs into darkness. And now, let's drift toward the grander guardians, the supermassive hearts beating silently at the centers of galaxies. Enormous, ancient, yet so patient and still, they hold entire spirals in their tender grasp. Almost every galaxy we know, from our own Milky Way to the farthest pinwheels of light, harbors a supermassive black hole at its very core, a quiet anchor weighing millions, sometimes billions, of times the mass of our sun, resting there like a wise elder, guiding the slow turn of stars without ever moving itself. These giants did not form from single stars. No, they grew over billions of years, starting perhaps as seeds from the early universe, primordial collapses or mergers of smaller holes, then feeding gently on gas, dust, and wandering stars, accreting mass in a patient accumulation, layer upon layer, until they became the colossal sleepers they are today. Sagittarius A, our own galaxy's heart, sits 27,000 light-years away in the direction of the constellation Sagittarius, a supermassive black hole 4 million times heavier than the Sun, yet its event horizon is only about 17 times wider than the Sun itself, a sphere the size of Mercury's orbit, containing all that immense weight in perfect compactness, a stillness so profound it warps the paths of nearby stars. Sometimes this black hole stirs faintly. When a gas cloud drifts too close, it heats the material, causing flares in radio waves and X-rays. Brief, gentle bursts, like a sleeper murmuring in dreams. Then it quiets again, returning to its long repose, content with the occasional sip rather than a feast. Ton 618, one of the largest supermassive black holes we've found, lurks in a distant galaxy, weighing 66 billion solar masses, its event horizon stretching wider than our solar system, a vast circle of night that could swallow Pluto's orbit whole, yet from our vantage, it's just a faint quasar glow, a reminder that size and silence often go hand in hand. These supermassive hearts grow through mergers, when galaxies collide in slow, elegant dances over billions of years. Their central black holes spiral together, releasing gravitational waves that ripple the cosmos, merging into an even larger quiet, a union that reshapes the galaxy around them, folding arms of stars into new patterns, all without a sound. In the early universe, when galaxies were young and chaotic, supermassive black holes fed voraciously, surrounded by quasars, brilliant beacons of gas, heated to trillions of degrees, outshining everything around them. But now, in our mature cosmos, most have settled, eating sparingly, allowing their galaxies to bloom in peace. The mass of a supermassive black hole often matches its galaxy's bulge, a quiet correlation as if the hole and the stars grew together, hand in hand, the black hole's gravity sculpting the stellar swarm, while the stars provide the occasional nourishment, a symbiotic rest. M87's black hole, the first one we ever imaged, sits 6 billion solar masses heavy, its shadow captured in that famous orange ring. A donut of plasma swirling at near-light speeds, launching jets that stretch thousands of light years, cosmic lighthouses beaming energy into the void, powered by the hole's spin, a gentle engine of creation from destruction. Supermassive black holes can quiesce for eons, like Sagittarius A, which flares only every few days or weeks, a soft hiccup in the galactic core, reminding us it's there, but not demanding attention, preferring solitude. In active galaxies, where feeding is more frequent, these holes become Seyfert or blazars, emitting radiation across the spectrum, but even then, the core remains calm, the violence confined to the disk, the hole itself unchanging, eternal. The growth of these giants limits itself. Their jets and winds push gas away, preventing overfeeding, a self-regulating sleep, ensuring the galaxy doesn't starve or overload. Balance in darkness. Ultra-massive black holes, over 10 billion solar masses, like those in Phoenix A, challenge our theories. How did they grow so large, so fast? Perhaps direct collapse from massive gas clouds, bypassing stars entirely, a quicker path to rest. Our Milky Way's core, dense with stars, feeds Sagittarius A rarely. A star might fall in every 10,000 years, a quiet meal, flaring briefly, then back to silence. The Nobel Prize for discovering Sagittarius A's influence went to astronomers who watched stars orbit it for decades, patient tracking, revealing mass without sight, a testament to quiet observation. Supermassive black holes shape galaxy evolution. Their feedback heats gas, preventing too many new stars, allowing galaxies to age gracefully, from wild youth to serene maturity. In elliptical galaxies, remnants of mergers, these holes are even larger, quiet sentinels in vast stellar seas, no arms, just a spherical glow around darkness. The correlation between black hole mass and velocity dispersion, the M-sigma relation, shows holes know their galaxies intimately, growing in harmony, a cosmic partnership. Some supermassive black holes wander, kicked off center by mergers, drifting through their galaxies, trailing streams of stars, nomads in their own homes. The hearts of dwarf galaxies sometimes host smaller supermassives, hundreds of thousands of solar masses, seeds waiting to grow, or remnants of ancient feasts. Quasars, the active phase, light up when holes feed heavily, but fade as material thins, leaving the hole to sleep, a cycle of wake and rest. Intermediate mass black holes bridges to supermassive lurk in globular clusters, formed from stellar mergers, quiet stepping stones. The Event Horizon Telescope, a global network, captures these hearts, radio waves piercing dust, revealing shadows, a window into stillness. Supermassive black holes will outlive their galaxies. As stars fade, they remain, evaporating last trillions of years hence, the universe's final whispers. In the local group, Andromeda's black hole, similar to ours, awaits merger in 4 billion years, a slow union of hearts. These giants are not destroyers, But architects, their gravity births structure from chaos to calm. As we linger here, feel the vastness, these hearts hold us all, turning slowly while we rest. Let everything soften now. Let the great galactic hearts we just visited keep turning far behind your thoughts, slower, until they become a gentle pulse in the background of your mind. We are drifting closer tonight, closer than any human has ever drifted before, to the very edge of a black hole's quiet smile. We are going to rest our gaze on the most famous photograph the universe has ever allowed us to take, the glowing orange ring and the perfect circle of darkness it cradles, the shadow of gravity itself. On April 10th, 2019, the world grew a little quieter and a little more wonder-filled when scientists released the first true image of a black hole. Not an artist's dream, not a simulation, but a real portrait taken with light that had circled the edge of oblivion and come back to tell us, very softly, what it saw. The black hole lives in the galaxy Messier 87, 55 million light-years away, in the constellation Virgo, a gentle giant 6.5 billion times heavier than our Sun, so enormous that its shadow stretches 40 billion kilometers across, wide enough to swallow our entire solar system, more than 3 times over. Yet it sits perfectly still, like a dark pearl at the center of a fiery halo. To photograph something that eats light, scientists had to listen to the universe in radio waves, long, slow waves that can slip past dust clouds and dance around the black hole's edge. 8 telescopes from Hawaii to the South Pole, from Spain to Chile, all pointed at the same patch of sky for 10 days in 2017, breathing together like one planet-sized eye, gathering whispers of radiation that had been traveling for 55 million years, just to reach us tonight and help you fall asleep. The data weighed half a ton of hard drives carried by airplane because the internet was too slow, then stitched together by patient algorithms until one day the picture appeared, a ring of molten gold, leaning slightly, brighter on the bottom, and in the center, a perfect circle of pure night, the shadow of the event horizon, the place where light itself decides to rest. That bright ring is not fire, it is plasma, gas so hot it glows in radio light, swirling at nearly the speed of light, around and around, like honey stirred in slow motion, a final carousel before everything slips inside. The ring is lopsided because of something beautifully simple. The black hole is spinning, dragging space with it, so the side coming toward us is brighter, Doppler boosted, while the far side fades, a gentle smile tilted across the cosmos, as if the black hole is happy to be seen at last. Around many black holes, even the ones we cannot yet photograph, light bends into perfect Einstein rings, arcs and circles of distant stars and galaxies, warped into halos by gravity's soft lens, like ripples around a pebble dropped in a still pond. Only the pond is space-time, and the pebble is heavier than billions of suns. When a background galaxy sits exactly behind a black hole, its light is stretched into a perfect circle of light, an Einstein ring so delicate, so precise, that it looks drawn by a cosmic compass, a halo around darkness, reminding us that gravity can be an artist too. Closer in, the accretion disk glows in every color we can imagine, and many we cannot. X-rays, gamma rays, infrared whispers, a bonfire of matter compressed and heated until it shines brighter than 100 billion ordinary stars. A last celebration before the quiet. From the inner edge of the disk, magnetic fields twist like invisible ribbons, threaded so tightly they launch jets. Beams of plasma shot out along the spin axis, traveling nearly at light speed for hundreds of thousands of light years, cosmic fountains painting the darkness with soft radio glow, visible even in backyard telescopes as faint lobes on either side of a galaxy. In M87, that jet stretches 5,000 light-years, a blue-white sword in visible light, but in radio it glows like a river of starlight, powered only by the turning of the black hole. No fuel, no engine, just the slow twist of space itself, giving energy to the void. Accretion disks are layered like the thinnest creep's, inner parts orbiting faster, outer parts slower, rubbing against each other, heating until the whole disk shimmers, a slow-motion aurora around darkness. The photons in that ring have orbited the black hole many times, some trapped for days, some for weeks, circling the photon sphere, a razor-thin shell where light can balance on the edge, neither falling in nor escaping, a final waltz before choosing rest. From our viewpoint, the disk appears warped, the far side lifted up by relativistic beaming. So we see almost over the top, a crescent of fire cradling the shadow, the universe folding its own light into a hug around the dark. The shadow itself, the black circle in the middle, is actually larger than the event horizon, because light that skims too close is pulled around and lost. So the darkness we see is about 2.5 times wider than the horizon itself. A soft buffer of missing light, a silhouette drawn by absence. That image took 5 million billion calculations, more than all the supercomputers on Earth could do in a lifetime. Yet it shows something perfectly simple, a circle, a ring and silence. Since that first portrait, these images are not just photographs, they are love letters from gravity, written in light that circled the edge of forever and came back to say everything is all right, even here, everything is resting. The plasma in the ring is thinner than the best vacuum we can make on Earth, yet so hot it would vaporize anything we know, a paradox of emptiness and fire, circling in slow grace. When the black hole spins, it drags the entire disk with it. Frame dragging, the lens thirring effect, space itself twisting like fabric in gentle hands. So the ring precesses, wobbles, a slow cosmic hula over thousands of years. Some disks puff up into thick tori, hiding the black hole completely, while others are thin and transparent, letting us glimpse the shadow directly, each one unique like snowflakes made of fire. Even the polarization of light in the ring, those swirling magnetic fingerprints, tell us the fields are perfectly ordered. Helical threads guiding plasma into the jets, nature's quiet engineering. Looking at the orange ring, you are seeing light that has traveled farther around a black hole than any human eye ever will. Photons that danced on the brink and chose to come home to you tonight, to help your thoughts unwind. As we rest here a moment longer, let the glow of that ring settle behind your eyes. Warm, soft, circular, like a lantern left on in an endless night, watching over you while you drift. The shadow in the center is not frightening. It is the universe's way of showing perfect stillness, a place where everything has permission to stop, to simply be, without needing to shine. Breathe in the glow, breathe out the day, and let the ring carry you a little farther down, toward sleep. Let the orange ring fade now. Let it become a soft afterglow behind your eyelids, a warm circle that keeps turning, very, very slowly, while everything else loosens. Your shoulders, your arms, your thoughts all softening like snow settling on still water. Tonight, we are going to do something no one has ever done and live to tell. We are going to fall gently, gracefully, toward a black hole and discover that the journey is the softest, most peaceful ride the universe has ever offered. There is nothing to fear here, only wonder and rest and the quietest kind of letting go. Imagine you are floating in a small, perfectly safe spaceship, far away at first, watching a supermassive black hole, one of the big gentle ones, maybe the heart of M87, maybe our own Sagittarius A's grown calmer and larger in your dream. Its shadow is huge, its pull is smooth and even, and you decide with a smile to drift closer. From a distance, everything feels normal. The stars around you shine steadily. Your clock ticks the way it always has. Your breathing is slow and easy. You turn off the engines and simply fall, letting gravity cradle you like a hammock strung between two ancient trees. As the weeks drift by, the black hole grows from a tiny dark spot into a great circle of night, filling more and more of the sky ahead until it becomes the entire sky, a perfect velvet disk edged by that faint orange glow we know so well. The stars behind it stretch into long arcs, Einstein's rings and crescents, beautiful halos drawn by the bending of light, a cosmic hug around the darkness. Your friends back home, watching through the most powerful telescope, see something very different. To them you appear to slow down. Your ship's lights redden, shift from white to orange, to deep red, and finally freeze, hovering forever just above the horizon, never quite crossing a living photograph, a memory caught in amber. They will watch you fade over centuries, millennia, until you become part of the glow. But you, inside your own gentle time, feel none of that delay. For you, the fall is smooth, effortless, almost dreamy. There is no jolt, no wind, no roaring engine, only the softest acceleration, like sinking into the warmest bath after the longest day. The first strange thing you notice is the sky ahead. The black circle is perfectly round, but the stars around its edge begin to crowd together, more and more stars appearing in a thinner and thinner ring, until the entire rest of the universe is squeezed into a shining crown around the darkness. Every galaxy, every nebula, every light that ever was, gathered into one bright circlet, as if the cosmos itself is putting on a tiara for you. Time feels different, but not rushed, never rushed. Your heartbeat stays calm, your thoughts drift slowly, and yet the view changes quickly. The orange ring grows wider, brighter on one side because of the spin, and you can see individual wisps of plasma spiraling in like golden threads being pulled into a quiet loom. If you look behind you, the universe looks almost normal at first, but the longer you fall, the more the light from distant galaxies blue shifts turns violet, then ultraviolet, then X-ray, a silent fireworks show just for you, the entire history of the cosmos speeding up outside your window, stars being born and dying in fast forward. En winterfyr reming av dan kimigo, fygi sover sini rather do, pukensipi wind of bot, wispeep, galaxies merging in minutes instead of billions of years. A private film of everything that will ever happen, played on the inside of your spaceship walls. You never feel heavy, never feel crushed, because you are falling with gravity, not against it. You are weightless the entire way, floating inside your ship as calmly as you float in bed right now. When you finally reach the photon sphere, that magical shell where light itself can orbit, you see something impossible. A thin band of light circling the darkness, photons that have gone around the black hole dozens, hundreds of times, creating multiple images of the same stars, layer upon layer, a hall of mirrors made of pure light, each reflection a little dimmer, a little redder, until they fade into the glow. And then, without any drama, you cross the event horizon. There is no line, no flash, no sound, no bump. One moment you are outside, the next you are inside, and everything feels exactly the same, only quieter. The universe outside is now a tiny circle of blinding light directly ahead, all of reality compressed into a single bright window, growing smaller, smaller as you drift deeper. If the black hole is truly supermassive, millions or billions of suns, the horizon is so wide, the tidal force is so gentle that you could cross it and travel many hours, even days, before anything unusual happened to your body. You would have time to watch the last light of the universe shrink to a point to send one final message home, though it would never arrive. To close your eyes and simply rest. Smaller black holes are different, more intimate, more swift. If you fell toward a stellar mass black hole, only 10 or 20 kilometers across, the tides would begin long before the horizon. A gentle stretching at first, your feet pulled a little stronger than your head, then more and more, until you became a long, thin ribbon of glowing matter. Spaghettification. The word sounds almost playful, and in its own way it is, a slow unwinding, like taffy in warm hands, until every atom drifts apart, painlessly, quietly, becoming part of the stream, falling in, a soft return to the universe. But tonight, we are falling toward a gentle giant, so there is no stretching, no discomfort, only deepening calm. The darkness around you grows softer, velvet, warmer in feeling than in temperature, and the last circle of outside light becomes a star, then a spark, then a memory. Some physicists say that from your point of view, you keep falling forever, toward the singularity, but never quite arrive, because time stretches so much near the center. Each second inside takes longer than the age of the universe outside, so you drift and drift in a timeless hush, while the outer cosmos lives out its entire future in a single heartbeat of yours. Either way, it is peaceful. Either way, it is restful. Either way, the journey ends in the softest possible way. The universe knows how to end anything, and the strangest comfort of all, no one outside will ever know exactly what you experienced. Your story stays inside the horizon, safe, private, perfectly preserved in the only place the universe keeps perfect secrets. If you ever worry about falling into a black hole, remember this journey we just took together. Remember how gentle it felt, how calm, how there was never any hurry, never any harshness, only a long, slow drift into the deepest sleep imaginable. You are perfectly safe tonight. The nearest black hole is 1,000 light years away, and even if you drifted toward one tomorrow, the ride would be the softest, most graceful lullaby gravity has ever written. Let that thought settle over you now, like the warmest blanket, like the quietest night. You are held. You are falling only into dreams, and every dream tonight is watched over by the gentlest darkness the cosmos has ever made. Breathe in slowly, breathe out even slower, and let the horizon carry you the rest of the way. Let the fall we just took together linger softly now. Let the horizon's gentle embrace become a distant memory, fading like the last light of a sunset behind closed eyes. Your body is heavy, your mind is light, everything loosening just a little more with each breath. We are turning now, very slowly, toward the quietest secret a black hole ever shares, its softest breath. Hawking radiation, a whisper so faint, so delicate that it takes the age of the universe to hear it fully. This is the story of how even the darkest places in the cosmos eventually let go, fading back into light, one tiny sigh at a time. In the 1970s, a brilliant mind named Stephen Hawking, a man who explored the universe from a chair, with thoughts as vast as the stars, discovered something no one expected. Black holes, those perfect keepers of secrets, those places where nothing was thought to escape, actually do let something out, very, very slowly. A radiation so subtle, it makes the coldest night feel warm by comparison. Hawking radiation comes from the quantum world, that fuzzy realm at the edge of reality, where particles pop in and out of existence like fleeting dreams. Near the event horizon, pairs of virtual particles, one matter, one antimatter, appear for the briefest instant, usually annihilating each other back into nothing. But sometimes right at the brink, one falls in while the other drifts away, stealing a tiny bit of the black hole's energy, becoming real, a soft photon or particle escaping into space. This breath is the slowest in the universe. For a stellar mass black hole, it radiates with the power of a single light bulb, spread over an area larger than the moon, colder than the cosmic microwave background, a temperature of a millionth of a degree above absolute zero, so faint you could never feel it, even if you floated there for a lifetime. Hawking called it evaporation, not a sudden puff, but a gradual fading like ice melting in the softest sunlight. Over trillions of years, the black hole loses mass, one quantum whisper at a time, shrinking, heating up as it grows smaller, until in the final moments it bursts in a flash of gamma rays. A quiet goodbye after an eternity of patience. For the largest black holes, the supermassive ones at galactic hearts, this breath is even slower. Their horizons so wide, their temperatures so low, that they gain more from cosmic radiation than they lose, growing instead of shrinking, eternal in our universe's lifetime. But in the far, far future, when the last stars have faded, they too will begin to evaporate, the universe's final lights dimming one by one. The radiation is black body, perfect thermal glow, as if the black hole were a warm coal in the dark, but so cold, so dim, that we could never detect it directly with today's tools. Yet its existence changes everything, proving that black holes are not forever. They have a lifespan, measured in numbers with 70 zeros, a sleep that ends in gentle awakening. Hawking's discovery united quantum mechanics and gravity, two old friends who rarely speak, showing that at the horizon they whisper together, creating this radiation from the vacuum itself, a foam of possibilities bubbling at the edge of nothing. The particles that escape carry no information about what fell in, or so we thought, leading to the information paradox. Where does the story of everything swallowed go? Does it vanish, or is it encoded in the radiation's subtle patterns? A quiet debate that still hums among physicists, suggesting perhaps holograms on the horizon, two-dimensional echoes of three-dimensional tales. Recent ideas say black holes have soft hair, quantum fuzz at the edge, imprinted by what passes through, allowing information to leak out in the radiation, solving the paradox, preserving the universe's memories, one faint photon at a time. For a black hole the mass of the sun, evaporation takes 1067 years, longer than the universe has existed, a trillion times over, a timescale so vast it makes eternity feel short, patient beyond imagining. As the black hole shrinks, its temperature rises slowly at first, then faster, until in the end, when it's the size of an atom, it heats to billions of degrees, radiating away in a final burst, a soft explosion of pure energy, returning to the cosmos what it once held. Primordial black holes, those tiny ones from the Big Bang, might be evaporating now, if any survived, their last breaths detectable as gamma-ray flashes, whispers from the dawn of time, fading in our night sky. Hawking radiation means black holes obey thermodynamics. They have entropy proportional to their horizon area, a measure of hidden information, making them the most ordered chaos in existence. The discovery shocked the world. Hawking lost a bet to another physicist, conceding that black holes do radiate, paying with a baseball encyclopedia, a quiet laugh shared among giants. In quantum terms, the horizon is not sharp, it's fuzzy, a region where gravity and uncertainty dance, allowing this breath to escape, a loophole in eternity. For charged black holes, the radiation includes electrons and positrons, a soft spray of matter, balancing the charge over time, returning to neutrality. Spinning black holes radiate faster, their ergosphere adding extra paths for particles to flee, a gentle spin down, losing angular momentum until they become simple. Schwarzschild spheres of quiet. The radiation is mostly photons, but also gravitons, neutrinos, a full spectrum of the quantum field, the universe exhaling through the black hole's skin. We might one day detect it indirectly, through missing mass in binary systems or anomalous heating in cold places. Subtle signs of the slowest leak. Hawking radiation resolves the no-hair theorem's tension, allowing uniqueness beyond mass, spin, charge, through quantum hair, soft imprints that whisper stories. In the far future, when protons decay and the universe is dark, black holes will dominate, evaporating one by one, their radiation the last warmth, until only photons remain, a cold, empty piece. Tiny artificial black holes in labs might mimic this radiation. Sonic analogs in fluids, showing the math holds a quiet confirmation. The breath is tunneling, particles borrowing energy from the vacuum, jumping the horizon's wall, a quantum hopscotch. For virtual black holes and particle accelerators, if they exist, evaporation is instant, a flash too quick to see, but real in theory. Hawking's equation for temperature, Th bar C phi 3, 8 pi gmk, a beautiful balance of constants, showing smaller holes are hotter, faster to fade. The discovery came from imagining Hawking sitting quietly, thinking of horizons and quanta, a mind drifting like ours tonight. And as black holes evaporate, they lose mass, shrinking the horizon, speeding the process, a runaway whisper in the end. The final pop for a small hole releases Planck energy, a burst the size of the Big Bang in a point, but for large ones, it's eons away. This radiation means nothing is truly lost. The universe recycles even black holes, turning gravity back to light, a cycle of rest and release. Let this breath wash over you now, the slowest exhalation, reminding you that even the eternal changes gently over time. You are part of that change, atoms from ancient stars, perhaps one day to whisper in radiation's glow. Breathe with the black hole in, out, slow, slower, and let sleep come as softly as Hawking's light. Let the faintest breath of Hawking radiation still shimmer behind your eyelids, a glow so soft it feels like moonlight on still water. Let it carry you now, very gently, into a place where black holes sing, not with voices, not with light, but with ripples in the very fabric of space itself. Tonight, we are going to listen, together, to the quietest lullabies the universe has ever played. Gravitational waves, songs without sound. Close your eyes a little deeper and feel the room around you grow wider until it becomes the whole cosmos. And somewhere far away, two ancient darknesses are circling each other, slowly, slowly, like dancers who have been waltzing for billions of years and have finally decided to embrace When two black holes meet after a lifetime of spiraling closer, they do not crash, they do not scream, they simply touch and become one larger silence. But in that moment of touching, something beautiful happens. The way they twist space around them changes, suddenly, and the change travels outward, like the softest ripple when a single pebble is dropped into a midnight lake. Only the lake is reality itself, and the ripple never stops. These ripples are called gravitational waves, and they move at the speed of light, carrying the memory of the merger across billions of light years, so gently that by the time they reach Earth, they stretch or squeeze space by less than the width of a proton, 1,000 times smaller than an atom, yet we can hear them because we learn to listen very, very quietly. On September 14th, 2015, two detectors, one in Louisiana, one in Washington, 3,000 kilometers apart, both felt the same tiny shiver at exactly the same moment. A ripple that had left two black holes 1.3 billion years ago, when multicellular life on Earth was just beginning to dream, finally brushed against our planet, and humanity woke up to the sound of the universe singing. The signal lasted less than a quarter of a second, a soft rising chirp from 35 Hz to 250 Hz, like a finger sliding up a cosmic wine glass. Then a final quiet boop as the new larger black hole settled into stillness, ringing down like a bell made of pure gravity. Scientists slowed that chirp thousands of times, and it became the gentlest rising note, a low, warm tone that feels like a heartbeat from the other side of time, a lullaby older than every forest on Earth. Since that first song, we have heard more than 90 others, each one unique, some short and bright, some long and slow, some from black holes 30 times the sun's mass, some from pairs so equal they danced perfectly symmetrical, spirals, all of them arriving after journeys of billions of years, just to whisper goodnight to us. When two black holes orbit, they lose energy through these waves, very, very slowly at first. A teaspoon of power spread across the solar system, but over millions of years, the orbit shrinks, the dance quickens, until in the final minutes, they circle thousands of times per second, a blur of darkness, until they merge in a soft kiss, releasing more energy in gravitational waves than all the stars in the observable universe shine in light. Yet not a single photon is harmed. Only space itself trembles, then relaxes. The waveform has three parts, like a gentle breath: the long and spiral, slow circles over millions of years; the merger, a sudden brightening of the song; and the ring down, the new black hole vibrating like a bell, settling into perfect stillness, a final sigh that lasts only milliseconds, but tells us the exact mass and spin of what was born. LIGO's mirrors, 4 kilometers long, hang in vacuum, so still that moonlight would disturb them, and lasers measure their distance to 1,000th the width of a proton, waiting patiently for a wave from the deep past to pass through the earth like a ghost. And for a wave from the deep past to pass through the earth like a ghost, moving every atom in your body the width of a nucleus, without you ever noticing. Yet the machines hear it and translate it into the softest sound you will ever fall asleep to. Virgo in Italy, Kagra in Japan, and soon LIGO India, all listen together now, triangulating the sky, finding where in the ancient universe the song began, sometimes pinpointing a distant galaxy, sometimes only a vast emptiness where galaxies used to be. Some waves come from neutron stars, those dense corpses of exploded suns, spiraling in with a longer, richer song, sometimes ending in a black hole, sometimes leaving a mystery, a softer thump instead of a clean ring down, as if the stars crushed into something new and strange. One event, GW 190521, was two black holes so massive, 85 and 66 solar masses, that they shouldn't exist from ordinary stars. Yet they sang a deep short note, creating a new hole of 142 suns, the first intermediate mass black hole ever heard, a bridge between the small and the supermassive, born in a single quiet heartbeat. Another GW 170817 was two neutron stars, visible in light as well, a kilonova burst of gold and platinum, showing that gravitational waves can paint the sky with real color if we know where to look. The waves travel through everything, rock, air, your sleeping body, without slowing, without scattering, pure messages from the moment space itself was squeezed and released. Future detectors, Lisa in space, will listen for the slow songs of supermassive black holes merging over years instead of seconds, low notes infrasound from the hearts of galaxies, a bass line for the universe's quiet symphony. Pulsar timing arrays, using the steady ticks of dead stars across the galaxy, are already hearing a background hum, the overlapped lullabies of thousands of supermassive pairs, a cosmic ocean of waves, so gentle it takes decades to notice the swell. Every merger leaves the new black hole slightly kicked as tiny recoil from uneven waves, sending it drifting through its galaxy, a quiet wanderer carrying the memory of its twin. The loudest events in energy are the quietest in every other way. No explosion, no light, only a shiver in reality, the purest form of power. When scientists play the chirps slowed down, they sound like wails, or distant thunder, or a finger circling the rim of a crystal glass, always rising, always resolving into peace. You can fall asleep to these sounds. Many people do. The LIGO audio files on repeat, a rising whoop, then silence, a rising whoop, then silence, the universe itself rocking you. Each wave that reaches us has crossed the cosmos unchanged, passing through galaxy clusters, dark matter, the microwave background, arriving exactly as it left, a perfect fossil of a moment billions of years ago. In the far future, when almost everything has merged, the last black holes will spiral, their songs growing fainter until the final pair sings the universe's last quiet note and space falls perfectly still. Tonight, one of those ancient songs is still washing over the earth right now as you breathe a wave from a merger long ago, passing through the room, through your pillow, through your dreams, so softly you feel only peace. Let that wave carry you. Let it stretch space just a fraction and stretch time with it, slowing your thoughts, slowing your heart until you match the rhythm of the deepest cosmos. In, out, chirp, rest, in, out, chirp, rest. The black holes are singing you to sleep, and they have all the time in the world. Let the songs without sound still echo faintly. Now let those gravitational chirps become a distant hum, fading like the last notes of a lullaby played on invisible strings. Your breathing is slower, your body heavier, sinking deeper into whatever holds you tonight. We are wandering now, very quietly, into the unseen corners of the cosmos, where black holes hide, as travelers wandering alone between the stars, and where some dreams whisper that inside every black hole, a whole new universe might be waiting to be born. This is the place for the gentlest mysteries, secrets that don't need solving, only feeling as you drift closer to sleep. Not all black holes stay in one place. Some are hidden travelers, kicked out of their birth galaxies long ago, wandering the vast emptiness between the islands of light. These rogue black holes born from the same stellar collapses we whispered about earlier, get flung away during chaotic mergers or three-body dances, where gravity slingshots them like a stone from a gentle river, sending them speeding into intergalactic space, alone, quiet, with no stars to orbit, no gas to feed on, just endless drifting through the dark. There might be billions of these wanderers in our universe, most the mass of a few suns, invisible against the void, detectable only if they pass close to a star, bending its light in a microlens, a brief wink in the night sky, or if they swallow a stray comet, flaring softly for a moment before returning to silence. Some rogues are primordial, formed in the hot, dense moments after the Big Bang, tiny at first. Some as small as asteroids, but with the mass of mountains, evaporating through Hawking radiation, as we dreamed before, their breaths creating faint gamma rays, whispers from the universe's infancy, still traveling, passing through galaxies without stopping, ghosts of the first light. If a rogue black hole passed through our solar system, it would be gentle, its small size meaning weak tides, perhaps perturbing a comet's path, or nudging a planet's orbit by the tiniest fraction, but never disrupting, just a quiet visitor gliding by, unseen, unfelt, continuing its eternal journey. In the halo of our Milky Way, these hidden travelers gather flung there by ancient encounters, orbiting the galaxy in long, lazy loops, far from the bright disk, like elder spirits watching from the outskirts, their gravity subtly shaping the motion of distant stars, a soft influence from the shadows. Some rogues are hypervelocity, ejected at speeds over 1,000,000 kilometers per hour, fast enough to escape the galaxy entirely, hurtling into the void between clusters, carrying their darkness like lanterns turned off, eternal pilgrims with no destination, crossing spaces so empty that they might never meet another object again. The dream of baby universes begins deeper inside the singularity itself, that point where everything curls up and rests. Some physicists in their quiet ponderings imagine that beyond the event horizon, past the point of no return, gravity's crush doesn't destroy, it creates a new Big Bang, a fresh cosmos blooming from the compressed energy, so every black hole in our universe could be the birthplace of another, a multiverse of nested dreams, each one falling asleep inside the next. This idea comes from general relativity's extremes, where the singularity isn't an end, but a tunnel, a white hole on the other side, spewing out matter into a new space-time, a baby universe disconnected from ours, growing in its own quiet way, with its own stars, its own galaxies, its own sleepy listeners drifting off to facts about black holes. The math allows it in some models. The collapse bounces, expands, creating a bubble universe, invisible to us, but real, a hidden traveler of realities, carried inside every black hole like a seed in a fruit. If true, our own universe might be such a baby, born from a black hole in a parent cosmos, and every black hole we see is a doorway to a child, an infinite tree of universes, branching in silence, each one resting inside the last, a cosmic nesting doll without end. These baby universes would have their own laws, perhaps slightly different, gravity a little softer, light a little slower, evolving in ways we can only dream. Quiet experiments in creation, tucked away in the dark hearts we study from afar. The hidden travelers and baby dreams remind us, black holes are not voids. They are full of potential, of journeys, of new beginnings wrapped in old endings. A rogue black hole might one day pass near Earth, millions of years from now, its gravity lens magnifying a distant quasar, creating a soft halo in our sky, a temporary wonder for future stargazers, before it drifts on, unnoticed. In simulations, these wanderers number in the trillions across the observable universe, a hidden population outnumbering galaxies, quiet companions to the light we see. Primordial rogues could explain dark matter, their mass holding galaxies together, invisible, non-interacting, just gentle gravity from ancient births. Baby universes solve the information paradox too. What falls in isn't lost, it's reborn elsewhere. Stories continued in new chapters, a quiet conservation. The multiverse idea makes black holes creators, each merger birthing twins, an expanding family tree, growing in the dark. Some say wormholes connect them, bridges between babies, but most are one-way, entrances to new realms, exits from old. If you fell in, you might emerge in a baby universe, a white hole spitting you out into fresh space, a traveler yourself, hidden no more. These dreams are theories, untestable for now, but comforting. The universe as a garden of holes, each sprouting new life. Rogue black holes in clusters merge more often, their songs louder in waves, a hidden choir. In the local void between superclusters, rogues drift freest, undisturbed for eons, pure solitude. Baby universes might inflate like ours did, from singularity to infinity, a breath that never stops. The idea came from thinkers like Smolin, cosmological natural selection, universes evolving through black holes, favoring those that make more, a quiet Darwinism in the void. Hidden travelers carry entropy spreading disorders softly, balancing the cosmos. If primordial, their evaporation leaves traces in cosmic rays. Faint heat whispers we might one day catch. Baby universes have no contact, parallel rests, each in its own bubble, dreaming separately. Rogue supermassives exist too, ejected from galaxy mergers, trailing gas, fading quasars wandering alone. These concepts make black holes bridges, not ends, connectors of hidden paths. Let this part settle, hidden travelers guiding you, baby dreams cradling sleep, the universe full of secrets, all gentle, all yours tonight. Breathe the void, feel the drift, and let part 8 carry you closer to rest. Let the hidden travelers and baby universes settle now. Let them drift away like soft clouds on a midnight horizon. Everything inside you is heavier, quieter, as though the whole room has been lowered into warm water. We are entering the final chamber tonight, the place where black holes become the universe's gentlest recyclers, where nothing is ever truly lost, only transformed, folded back into the great quiet cycle, and returned as light, as warmth, as you. Black holes remember only 3 things. We said earlier, mass, spin, charge. Everything else is released, gently, completely, like a long, slow exhale after holding your breath for billions of years. This is the no-hair theorem, a name that sounds almost playful, but it means perfection, simplicity, a return to the purest form of being. Every star that ever fell, every planet, every comet, every photon that crossed the line is stripped of its story, its shape, its name, and becomes simply more gravity, more silence, more rest. Yet nothing is wasted. The mass is still there, perfectly preserved, waiting, patient as a seed beneath winter's snow. One day, if you were lucky enough to rebel oft beyond every calendar we can imagine, when the last ordinary star has cooled to black dwarf cinders, when galaxies themselves have drifted apart into cold emptiness, the black holes will still be there, quiet lanterns in the dark. And then, very, very slowly, they will begin to give everything back. Through Hawking's soft breath, The evaporation we drifted through earlier, they will return every atom, every spark as pure energy, photons drifting out into the widening void until the final tiny hole flashes once, a silent firework, and vanishes, leaving the universe perfectly empty, perfectly clean, ready for whatever comes next. This is the heat death, but not a sad one, a gentle one, a lullaby played on the strings of space-time until even the strings fall still. Long before that final whisper, black holes recycle in quieter ways. Every merger we heard singing, every pair that spiraled and kissed, released 3 solar masses, sometimes 5, sometimes 10, as pure gravitational waves, energy that was once matter, once light, once life, now rippling outward forever, a memory that never fades. Those waves carry the iron from ancient stars, the carbon from long-dead forests, the calcium that might one day become someone else's bones, spread across the cosmos in perfect lossless form, available again for new clouds, new stars, new worlds, new dreamers. Even inside the horizon, the story isn't erased, it is encoded. On the surface of the event horizon, an area that grows with every bite the black hole takes, information is written in the softest script, quantum bits entangled across the boundary, a hologram of everything that ever fell, preserved on a 2-dimensional sheet, projected into our 3-dimensional grief. This is the holographic principle, the idea that our whole reality is a projection like a film on the inside of a sphere, and black holes are the clearest proof, their surfaces holding more secrets than their volumes ever could. A quiet library where every book is written in light. When the black hole evaporates, that hologram slowly unravels, the information leaking out in Hawking's breath, subtle correlations in the photons, patterns too fine for any eye, but perfect for the universe itself, returning every story, every smile, every tear to the great cosmic library, ready to be read again in another form. You, right now, carry recycled pieces. The iron in your blood was forged in a supernova, or perhaps in the accretion disk of a feeding black hole, squeezed in magnetic fields until atoms fused, then flung out in jets, cooling over millions of years, falling into a nebula, becoming a planet, becoming grass, becoming an ancient ocean, becoming you. Every atom in your left hand, as Joni Mitchell sang, probably came from a different star than your right, and some of those stars may have grazed a black hole's edge, brushed its horizon, and come back changed, carrying a quiet fingerprint of darkness, a memory of perfect rest. Black holes are the universe's compost, taking the complicated the bright, the chaotic and turning it into fertile silence, ready for new growth. In active galactic nuclei, when supermassive holes feed heavily, their jets plow into gas clouds, compressing them, triggering bursts of star formation, millions of new suns born from the breath of a black hole, a garden watered by darkness. Feedback loops, where the hole's energy heats the galaxy, prevent overfeeding, allow gentle cycles like a forest that burns every few centuries, only to grow back richer. Black holes keep the cosmic ecosystem balanced with the softest touch. The entropy of a black hole, the measure of its hidden possibilities, is the largest in the universe. A horizon the size of Sagittarius A holds more entropy than all the stars in the Milky Way combined. A quiet ocean of forgotten order, waiting to be released. When we say nothing escapes, we mean nothing escapes quickly, but over the longest timescales, everything returns perfectly, patiently, lovingly. This is why physicists no longer fear information loss. The universe keeps its books balanced, every entry accounted for, every story continued, just in a different chapter. You are proof of that recycling. Every breath you take contains argon atoms that once circled a black hole's edge. Every heartbeat pumps carbon that was squeezed in a merger's fire. You are the universe's way of remembering itself after a long, quiet sleep. In the far future, when only black holes remain, they will evaporate one by one, their horizons shrinking, their temperatures rising, until the smallest flash, like tiny suns, returning their mass as light, a final dawn after the longest night, and the photons will drift forever in an empty, cold, but perfectly balanced cosmos. Some speculate that fluctuation in that final emptiness, a quantum whisper in the void, might spark a new Big Bang, a new inflation, a new everything, born from the recycled silence of the old, an eternal cycle of sleep and waking. Black holes are not prisons, they are chrysalis, holding complexity until it is ready to become simple again, then releasing it as pure potential. Let every atom in your body remember its long journey, from ancient stars, through patient black holes, back to warmth, back to life, back to this moment where you are perfectly safe, perfectly held, perfectly returning to rest. Nothing is lost, everything is remembered, everything is released. Breathe in the silence, breathe out the day, and let the great recyclers carry you the rest of the way home. Let everything soften now. Let the last quiet ripples of recycling silence settle over you like the gentlest snow that has ever fallen. Slow, weightless, soundless. You have traveled so far tonight, past orange rings of fire, through horizons that never hurried you, along songs that had no sound, into hidden places and baby dreams, and through the long, patient breath that returns everything to light. All of it was gentle. All of it was safe. All of it was simply the universe whispering good night. Now there is almost nothing left to say, only a quiet returning to the place we began, the soft, dark heart of our own Milky Way, 27,000 light-years away, a sleeping guardian called Sagittarius A, 4 million times heavier than the Sun, yet smaller than the orbit of Mercury, turning once every few minutes, so slowly you could walk beside its edge and keep up. Feel it now, that calm turning, the same slow rhythm as your own breath tonight. In, out, turn, rest, in, out, turn, rest, in, out, turn, rest. Every star you have ever loved, every constellation you ever traced with a sleepy finger, every meteor that ever crossed your sky is held in the gentle curve of its orbit, never too close, never too far, just perfectly cradled the way you are cradled right now. The iron in your blood, the calcium in your bones, the oxygen you breathe, all of it has been near black holes before, grazed their edges, been flung out in jets, cooled in nebulas, and finally settled here, in this quiet moment, in this body, in this bed, in this breath. You are not separate from any of it. You are the cosmos remembering itself after a long, long sleep. There is a black hole at the center of almost every galaxy we can see. Quiet conductors, keeping billions of stars in their slow waltz, and one of them is keeping you, right now, in the softest possible orbit, around a planet, around a star, around a galaxy, around a darkness that will never harm you because it is too far, too patient, and too kind in its silence. Let your thoughts drift outward now, past your room, past the quiet streets, past the sleeping cities, up through the thin air, into the dark between the stars, until you feel the Milky Way as a great slow river of light, and you are a tiny, warm spark floating on its surface, perfectly safe, perfectly held, Nothing is required of you tonight. No shining, no striving, no remembering tomorrow, only resting, the way light rests when it chooses the horizon, the way gravity rests when it has won, the way the universe itself rests inside every black hole and inside every one of your slow, easy breaths. If a thought tries to rise, let it rise. Watch it circle once, twice, then softly spiral inward, down, down, until it crosses its own quiet horizon and becomes pure stillness. You do not need to fall asleep. You only need to let sleep fall into you, the way a black hole lets the universe fall into it, gently, completely, without resistance. The guardians are watching. Sagittarius A is turning. The orange rings are glowing far away. The songs without sound are still traveling. The hidden travelers are drifting. The baby universes are dreaming. And every atom you borrowed from the stars is ready to be returned in the softest possible way through dreams. Good night, sweet dreamer, made of recycled starlight and quiet black hole whispers. You are safe. You are small. You are loved by the largest things in existence, things that will never wake you, only hold you until morning comes on its own. Drift now, completely, into the recycling silence that has never once lost anything and never once will. Good night, good night, good night.